students. So in this class we will start the lectures on complex analysis. Now you all must know that if you write a number, say 2 plus I3, this is a complex number where this is the real part and this is the imaginary part, and the I is actually the imaginary part. It means root over 1. So this is what will be known as a complex number. Now instead of writing 2 plus 3i, if we write a plus ib, where a can take any numerical value and also b can take any numerical value, then this becomes a complex variable. So this is a complex number. Where this is a complex variable. Apart from this, we have something called a complex function, where instead of writing a, if it is being replaced by a function of x and y, and in place of b, if we replace it by another function of x and y, then we call it a complex variable, and it is often denoted by f z. So this is complex variable. Now a complex number can be written in polar form as well. For example, if we take this complex number 2 plus I3 and we represent it graphically, say this is equal to, say, z. So this y-axis, this x-axis represents the real part of the z, and this x-axis represents the imaginary part of z. So real part means 2, so 1, 1, 2, this one, and imaginary part means 1, 2 and 3. So the point lies somewhere in between here. So this is basically 2 plus I3. Okay, now if we draw the radial line, and if we have an angle theta, and the length of the line is r, so this point can be represented as r cos theta plus I sin theta, and you know that e to the power I theta is equal to cos theta plus I sin theta. So we can write the complex number as r e to the power I theta. So this is the polar form of representing a complex number. Now the next part is when we say that a complex variable or a complex function is analytic or is differentiable. Suppose you have a complex function fz is equal to uxy plus I pxy. Now, to find out whether a complex function is analytic or not, there are certain rules which are called Cauchy Cauchy-Riemann conditions. According to Cauchy-Riemann conditions, if del u by del x is equal to del v by del y and del u by del y is equal to minus del v by del x, then we can say that the analytic complex function is analytic, otherwise not. It is another condition. And if we find the complex function fz is analytic on a certain closed region, it's called contour. So if fz is analytic, then the closed contour C fz gz is equal to 0, and this is called Cauchy's integral theorem.